Hi all, welcome to our talk. We are happy to have presented last year about how we moved with the ABN AMRO Bank towards cloud by using containers. And this year we're happy that we can present again at this awesome event. And we would like to share a story about how ABN AMRO Bank switched cloud providers without anyone noticing. So in the background of my slide, you see a beautiful landscape with clouds and a reflection, and it looks all very peaceful. And this is actually what you hope for when you're about to switch clouds, that the one cloud and the reflected cloud look more or less the same. So at ABN AMRO Bank, we switched from AWS towards Azure as a target platform. And we can say that in practice, the reflection might look a little bit different than the original picture. But before we start talking about that, I would like to introduce ourselves. I'm doing this presentation together with my colleague Mike Ryan. He's a DevOps consultant in a team within ABN AMRO Bank that is responsible for the managed container platform. And I'm Laura Rehorst, and I'm the product owner of that team. Before we dive into details of switching clouds, I think it's important that you know some background of what ABN AMRO Bank is. We are the third largest bank in the Netherlands, and we are active in the financial sector. And when you're active in the financial sector, you're active in a highly regulated sector. So there are a lot of restrictions you have to deal with. You have to deal with auditors. You have to implement a lot of controls. And of course you should, because we are responsible for very sensitive data of our customers. And we have applications that need to be available 24/7. That is really important for us to keep on doing. Another challenge that we have is that we have 20,003 plus employees. So we are quite a big organization. And as a bank, we already exist for a couple of 100 years. And we started, of course not started, but we are right now, a lot of our applications are on-prem, on physical data centers. And at a certain point in time, the bank made the decision to move towards cloud, follow cloud-first strategy. You can imagine that has a big impact, not only on the applications, but also on the teams. So what we did, we started guiding the teams in transforming into DevOps teams. So that's different responsibilities than they're used to, but also has a different mentality. And they will need to extend their skill set and their knowledge level. So that was the first journey we need to take before they could actually go into cloud. And we started with AWS as the first cloud, and that cloud was being prepared, put a container platform on top of that, and later on we did the same for Azure. So we have about 686 teams within ABN AMRO, DevOps teams, and those are all responsible for 2,836 applications running. So the teams that were ready, DevOps, and ready to go to cloud, often prefer to use containers to bring their applications towards cloud or to build their new applications on the cloud. And the thing with containers is it's very useful, but there are a lot of ways you can work with it. And also we saw that Kubernetes has a steep learning curve. So the bank decided it's important that we have a dedicated team that is guiding the teams on how to work with containers, so create best practices, and also create a managed container platform. And that team is called Stratus. Mike and myself are both part of the team. It's important to know why would you actually have a dedicated team. So I will explain to you the vision. And the vision, let's take the slide. Okay, so we are building a solid container platform. Why would a team not do it themselves? Well, if you have about 600 teams that want to use containers and everyone would need to build their own mini container platform, it would become unmanageable. As a company, you cannot control it, and there will be a lot of reinventing the wheel. And that's something you don't want, because then teams are wasting their time, their valuable time. So therefore, it would be good if one team would build a strong foundation where the other teams can build on top of that. Also, we are responsible for lifecycle management. So the container platform I just mentioned consists of a lot of components, and they need to be upgraded and patched. So that we take care of. Furthermore, we create a first set of reusable components. So think about Helm charts, Docker images, pipelines, Terraform modules. So it's the concept of inner sourcing, so that other teams can just reuse and build on top of that. Well, as I mentioned earlier, we have that great responsibility, and security and compliance are very important. So we need to make sure that containers are built and run in a secure way. And also that we enforce, for example, policies to make the clusters compliant. Sustainability is also an important part of what the dedicated team should do. It's as a team with a lot of knowledge, so therefore can also look into the future, what might happen in the future, and see how these new developments can contribute to sustainability. This can help with cost savings, but also with saving the environment. How can you do things more efficient? And last, but certainly not least, we do consultancy and support. So for use cases that are present within the bank, we can consult, share our knowledge on how they should pick up a certain use case, and we give support for the teams that are using our platform. So this is the component overview I mentioned. So when we started, we first went to the drawing table and created a capability overview. So what capabilities were needed by teams to start using containers. So we used the CNCF landscape as the model. And then we started filling in the tools to fit these capabilities. And there we made a decision that our approach would be to be as cloud agnostic as possible, because well, that would help us if we need to build it for both clouds. So in this example, you can, for example, see we use Helm, we use Terraform, Nginx, OPA, Twistlog. Those are all examples of cloud agnostic tools that you can reuse on both platforms. But choosing cloud agnostic tools can be very time consuming because you need to do a lot of market research, you need to do proof of concepts, make a decision and implement it. And yeah, we did not have 5 years for building this platform. No, it should be done in 1 year. So we needed to be a bit more pragmatic. And therefore we decided to also look into the cloud native services, just to see where we can speed up and see if the solution would be good enough. So there you see also some examples in this picture. Quickly going through it. On the left, you see Helm. We use it as a package manager to deploy the application and resources onto the clusters. We use Azure DevOps to build our pipelines, for example, Docker image pipeline, Helm pipeline to create your, or a pipeline to create your clusters. We use Kubernetes as an engine of the platform, and there we use the managed services, the native services, EKS and AKS on AWS and Azure. We use Nginx as an ingress controller for layer 4 and layer 7. Persistent storage is being filled with native services, Azure file storage and elastic file storage. Container runtime, we use at the moment Docker, but yeah, we use the standards so that can easily be replaced by, for example, Containerd. We use for networking the cloud native services called CNI. Terraform is used for infrastructure as code. For artifact registry, we use the native services ACR and ECR to capture our Helm charts and our Docker images. But on the background, Nexus is running, and that is actually our golden source. So both other registries are connected to that golden source. Then on the right, we have a lot of security features. So Prisma Cloud Compute, previously known as Twistlog, we use for scanning our containers, both in build and runtime. We use OPA, Open Policy Agent, to implement and enforce policies on clusters. We use HashiCorp Vault for secrets management. And on the right, for logging and monitoring, we also use the native services. So, and then company makes a decision to move from one cloud to the other. And you can imagine that has a great impact on, on the company itself, but especially for teams that are already on AWS working or that are about to move to AWS. So they started to onboard. And a lot of teams already started moving towards AWS. And that also means that they are now getting used to a certain way of working, and they also are consuming the native services on that platform. So if you then introduce a new platform, Azure, then you either have to tell them to stop working on what they're now doing, because otherwise they will need to rebuild a lot later on. That would, of course, be a lot of extra wasted time. But in real life, you cannot tell teams to just stop doing what they're doing and let them wait until you finish the platform. So here is where the container platform comes in place. We use a container platform as an intermediate platform where a team can onboard. They can work there with containers, they can get used to Kubernetes, and just keep on building. And in the background, we can do the heavy lifting and start preparing the new cloud environment, in our case Azure. And when the time is ready, they can just all move towards Azure, and the workloads that remain can, of course, remain on AWS. And it actually worked pretty well, because an example is the Smile team within ABN AMRO. And they were building on EKS, Kubernetes services of AWS. And while we were preparing on the background, at a certain point, we were finished. And we could just easily migrate them with some help. And now they can run into production on Azure. So that's in short how our abstraction layer looks like. And now I would like to give the words to my colleague, Mike Ryan.
Hello, virtual KubeCon people. I hope you liked our very smooth social distancing presentation handover. So I'm one of the engineers in the Stratus team, helping to build out the cloud native platform. Now, this is a very high-level overview of one of our deployment pipelines. Please don't worry about looking at the details. The idea is that this is a 10,000 feet overview. This is the pipeline we created for delivering Helm-based applications on AWS. Our customer teams use Helm for delivering their applications, and Stratus uses Helm internally for delivering the components of the platform. So this pipeline represents us building a Helm chart, delivering it to a Kubernetes cluster in a development environment, performing some integration tests, promoting it to an acceptance environment, performing some more tests, and then finally releasing a final version of the Helm chart. When we started building this, we knew we would first target AWS, but multi-cloud was always in our strategy. So we knew we would have to go to Azure at some point. We just decided to do AWS first. Because we had this mentality from the beginning, we were thinking in very high-level components of what we are trying to achieve for the business, rather than thinking about specific cloud provider tools and how to use them. So we came up with this very high-level design, and we're now going to play a game of Spot the Difference and look at our same pipeline on Azure. Just go back and let everyone have a chance to see the differences here. Yeah, so you've probably noticed they are actually the same image. And that was a conscious design decision we made from the beginning. By thinking in these terms of high-level functions, we could compose them together in a way that would work across both clouds. So when it came time to implement this delivery pipeline on Azure, we were using Azure DevOps instead of code build or code commit, and we were delivering to an AKS cluster rather than to an EKS cluster. But fundamentally, the pipeline's purpose and consumption remains the same. So for our developers, we could give them the same pipeline, whether they're on AWS or Azure, and things pretty much work exactly the same. So we'll look at a couple of examples of things that went well with the cloud agnostic approach, and then other places where we didn't necessarily follow that and why. So here is an example of an excerpt from one of the pipelines we use. When we deliver an application to a Kubernetes cluster, we apply some OPA policies, and OPA is running inside our Kubernetes cluster. The pipeline will reach out to the target cluster. OPA will validate what is about to be deployed, and then it will either be accepted, or if it breaks compliance rules, it will be rejected. Now, when we look at the same side on Azure, you see conceptually it's exactly the same. We have OPA running inside our Kubernetes cluster. The pipeline calls out to OPA, and everything continues working the same. So from the perspective of our compliance team, it doesn't really matter what cloud they're on. We know that this rule set will be applied by the pipeline. So this was one of the wins we found. And let's take a look at the actual rules. So this is an example of the rule we apply for checking load balancer policies on AWS. As a bank, we do not want developers creating internet-facing load balancers for pretty obvious reasons. So one of the things we do is block the creation of public-facing internet load balancers. This error message you see here refers to a specific control which has meaning within ABN AMRO. So if somebody sees this error message, they can go into a central information repository and look up what does this rule code actually mean, how do I mitigate it, why is it here, and so on. So if a developer tries to deploy something that is non-compliant, we will fail the deployment and give them a very descriptive error message of why we've blocked it, so they can go and figure out how to get themselves unblocked. So this is how it looks on AWS, and now let's look at the Azure side. Again, very similar. On AWS, we are using an application load balancer and the ALB ingress controller. On Azure, we are using the Nginx ingress controller. So from the Kubernetes perspective, both of these things are ingress objects, which have some annotations. So we are able to take the same compliance checking approach on either cloud, and the only difference is the annotation that we're checking. So this lets us use the same compliance code base across both clouds, which obviously keeps the security teams very happy. We could even take this further. The OPA language Rego is very powerful, so we could modularize this further such that we have one policy and the policy engine knows which cloud it's on and then checks for the right tag. So we still have some deduplication work to do here, but we're very happy that we can have one policy set and apply it across both clouds. So one example of where we did not follow this approach is with persistent storage. We started off with teams on AWS, and they picked up EFS, the EFS provisioner, to use an elastic file system from Amazon. This mounts a volume into their container, and then they can just access it from their application as if it were local storage. And now on the Azure side, we have something slightly different, which is the Azure file system provisioner. From an application perspective, these are the same. You have a mounted volume which your container can access, application can go do its thing, everyone's happy. When it comes to deploying this, there are some slight differences. Now, the differences are only in the YAML files which are used to deploy. You either say, I want an AFS volume or an EFS volume with some slightly different tags and annotations. Because the difference is quite minimal, it's not disruptive for teams to have to use one or the other, we decided to stick with the cloud-specific solutions rather than picking up a cloud-agnostic storage solution. It had been on our roadmap to evaluate the cloud-agnostic storage solutions, but as the organization took the decision that all new workloads and the majority of existing workloads would all be shifted to Azure, it was suddenly less important for us to have a cloud-agnostic solution. So we wanted to be pragmatic and say it actually makes sense in this case for us not to do it cloud-agnostic and have each team pick the provisioner that they need. When it came time for a team to move from AWS to Azure, they needed to change the YAML describing which provisioner they wanted to use for file storage, but they did not need to change their application to have it working because it's all a mounted volume from the perspective of the container. So because of that, we decided to separate this and use cloud-specific storage on each cloud. Okay, and that brings us to our lessons learned. So we learned a lot of lessons here and then had to distill them down into 3. The first one is, no matter how wonderful Kubernetes is, and it is very, very wonderful, it is not magical. You will need to do some work to get things working across cloud. You won't be able to just lift and shift something from Azure to AWS or vice versa without spending a ridiculous amount of time in building your own abstraction layers, which is not really a good return on investment for us. So Our perspective is better to take advantage of Kubernetes as much as possible, but still acknowledge that we will need to have some cloud-specific things in the platform at various points. The second lesson learned is to be pragmatic. There are millions of different choices in the cloud-native landscape. Many of them all perform their goal, and some people have different opinions about others. We needed to really just be pragmatic and think, what do our teams need? What is the best way, most sustainable, maintainable, scalable way for us to meet those goals without getting hung up on technology choices? The final lesson is one I believe we mentioned in our last one, but it's worth repeating. Automate from the start. We did a lot of automation from the beginning, but not 100%. Aiming for 100% automation is like aiming for 100% coverage on your test results. It's a laudable goal, but you get diminishing returns as you get there. However, we did realize that we maybe erred a little bit too far on the side of manual things. Despite having lots of automation, we still had a few things around testing which were manual, and over time the cost of doing those manually started to add up. So with hindsight, we could have better automated those, but that's always going to be a balance when doing something like this. You could spend 6 months automating something and have a beautiful automated system that nobody is using, or you can have an 80% automated solution that has customers on it, and we chose for the second one. So that brings us to the end of the presentation. We look forward to answering your questions. Thank you very much for listening. Cool stuff. So thank you everyone for watching, and some of the questions are coming through. We're answering those now. So one of the questions that came through, I'll answer this verbally, is how did we decide to move to Azure, and do we have any guarantees about where data is stored? The decision to move to Azure was a strategic decision taken at the higher levels of the company, and we have data storage will all be within the EU. So we're not sending data to the US. Okay, and another question is, why did you choose Azure for your go-to cloud provider and not staying with AWS or migrating to GCE? Azure and AWS were always target platforms. GCE hadn't really been on the radar, so it wasn't really a potential contender when we were deciding to switch. And as mentioned, this was a management decision to go towards Azure. So yeah, it sort of came down, and then we needed to implement it the best way we could. Okay, and the next question is a great presentation. Thank you. How much of your application landscape is currently in containers? Laura, do you have a ballpark for this?
Yeah, so right now it's still, well, there are not a lot of workloads yet in containers because we are migrating from on-prem towards the cloud as well. So all the workloads on-prem there are still in containers, and most of the workloads are on-prem still. So it's only a small percentage right now that's in containers in cloud.
Okay, and the next question is, using your container platform, are you still able to leverage cloud-specific SaaS offerings, or are you building everything on top of IaaS VMs, perhaps AKS, EKS? We try and be pragmatic here. If the cloud provider offers a service that does what we need, then we do not want to rebuild that. The whole purpose of our team is to prevent other teams from reinventing wheels. So if we are then going to go and invent our own wheels, it's pretty hypocritical and undoes the benefits. So we make great use of the cloud provider services. So for example, the basic ones being storage, we use a lot of that where we just plug into dumb storage, but also SaaS and application level things. If they do the job well, if they fit our needs, then we're not going to build something and run it ourselves just to say that we have. Okay, the next question is, did the teams have to migrate from AWS to Azure, or did you just do that transparently? aka how did they know about it, or is it all abstracted away? So last year we gave a talk called From COBOL to Kubernetes, and we had a complaint that there was no COBOL code examples. And I have to confess, we told a little lie in our presentation title. Some people noticed that we switched cloud providers. And yeah, we practice a setup of DevOps teams. So it's up to the DevOps team to migrate to the new cloud. Our job was to facilitate that as much as possible and to make sure that the environment they were landing on in Azure was as similar as possible to the environment they left on AWS, and to try and do as many things we could to ease that journey. So, for example, providing the same compliance tooling, file storage connections, and so on that they were used to on AWS. So there was still some work involved for the teams, and especially if they were using cloud provider services. So if they were using S3 on AWS, they had to rework their application to get it working on Azure. But if they were just using dumb storage attached to the container, then there was no rework required. So it really varied on a case-by-case basis. Okay, and another one. Why you selected Kubernetes over VMs? Can you give some thoughts on how much resources can be saved between the two approaches and how to select one over the other? So in terms of benchmarks, I can't give good numbers or good benchmarks and comparisons on the internet. Our view is that containers are much more lightweight and efficient. When people are building on containers and VMs, they tend to deploy more frequently, more quickly, and less painfully. And we see the industry moving towards containers rather than VMs. So we don't really want to be stuck in VM land when everyone has moved to containers. We also find them, frankly, speaking for myself personally here, I find VMs quite a pain to use sometimes when I'm doing development of infrastructural things, because there's lots of waiting time. With containers, I can spin up and scale up a lot more quickly. Okay, I think that brings us to the end of the questions. So thank you all so much for listening. Laura, any closing words?
Well, thanks for listening, and great that we could share a story on KubeCon again.